triangle bisectors, starting off with a perpendicular bisector theorem. If a point is on the perpendicular, I'm not going to spell all that out, bisector of a segment, then it is equidistant from the endpoints of these segments. First off, what does equidistance mean? Just means this just means the same distance. Oh my goodness. Distance. Okay, so what does that mean for our triangles? If our line here, CD, is perpendicular, remember this means perpendicular to AB, and perpendicular means that they form this right angle on both sides, right? And AD is congruent to DB, then also AC is congruent to CB. Means that these are congruent to these. So if perpendicular and our two are congruent, then the other two legs are congruent. The opposite is also true. I didn't put the converse of this theorem, but if we have our perpendicular bisector, this one in yellow, and AC and CB are congruent, then we know that AD and DB are congruent. So we can flip these and the same is true. So example, find the value of x. Look, we have our perpendicular bisector because it creates a right angle. And it tells us that these two legs, our base, are congruent. So that means that these have to be congruent. What does congruent mean? That they're the same. So I can set 7x plus 24 equals to 13 minus 48. Solve for x. X is 12. That's it. They're equal to each other. This one today is easy because all we got to do is set everything equal to each other. So find EG. So this is what I was talking about. If we know that this is our perpendicular bisector, and now we know that these two legs of our triangle are congruent, these have to be congruent. So I can set them equal to each other. 2x plus 11 equals 14x minus 37. Do the math, x equals 4. Go back to your problem. What is it asking for? It says, what is EG? EG is this one right here, so I need to plug in 4. So 2 times 4 plus 11, that's 19. So this is, EG is 19. This was your, oh man. This was your answer here. All right, angle bisector theorem says if a point is on the bisector of an angle, that should be an angle, then the point is equidistant. There's that word again, same distance from the sides of an angle. Okay, what does that really mean? You see, we got our triangles here with our bisector. So if AD bisects BAC, so this angle right here, and what did I do? Oh, sorry. And we know that AB is perpendicular to BD, creating this right angle, and AC is perpendicular to CD, creating this right angle. Then what has to be true? BD has to be congruent to DC. So BD has to be congruent to DC. Okay? So the converse of this theorem is about the angles, that if all of this is true, then this small angle in this triangle is congruent to this small angle in this triangle. So let's look at some examples. We have, find the value of x. We've got these two triangles put together. We have this angle being bisected. We've got our right angles being created because we have perpendicular lines. So that means that this equals this. So 4x plus 30 equals 9x minus 5. Solve for x. X is 7. Okay, I said that kind of the converse or opposite of this theorem has to do with the angles. So we've got everything true. We know that these two are congruent. We got our perpendicular lines with our 90 degrees. And this angle is being bisected. Bisected means that these two small angles are going to be congruent. So 5x minus 11 equals 8x minus 41. X equals 10. So that is all for our triangle bisectors, perpendicular bisectors, and angle bisector theorems. They just are telling us what is congruent. If certain things are true, creating these bisectors, what is congruent? Let me know if you have questions.